Okay, welcome everyone. This is the week two webinar. So we're now in more of a regular week because it's just a single webinar. And just to remind you, this is being recorded. So, it'll be put onto YouTube and be made public. So just let you know that. And so what we're going to be doing is, as always, I'll answer any questions you might have. That could be right away. It could be throughout the whole webinar. Always have one eye on the chat box. And then we're going to move on to chapter three.
No, stop.
So we're going to look at chapter three.
Oh,
And
wait.
huh? If you have any questions, probably chat box best. I'm going to mute you because it looks like there you get muted. So it's chapter three. And I just want to give you kind of a warning. Uh, Last week we did two chapters. Next week we'll do two chapters. This week we do one chapter. Does that mean it's easier this week? What do you think? Yeah, no. So I want to give you a big warning, and that is a lot of students think chapter three is the hardest chapter of the whole book. So just be ready for it. It won't necessarily look hard to watch me do it, but doing it yourself is much different. And what chapter three is all about is probability. So we'll start out what is a definition of probability, and then we'll do some examples of probability, and then we'll look at and then a little fun application, and that's buying a lottery ticket. It's going to win. So, what is the probability of winning the lottery if you buy a ticket? And we'll talk about it. And then these look really easy, and that sound easy. But again, there's a lot of language in vocab and sometimes you see the word and you have to deal with it probability wise. Okay. Sometimes you can have something with the meaning of and you have to deal with that. Same thing with or. It's another word that's really important. And another word that's important is given. So those are going to be some important words we're going to be doing. And then we're going to be looking at what it means for two events to be mutually exclusive. And then we'll say, what does it mean for two events to be independent? Okay. So again, most people do not have a hard time listening to me. What they have a hard time is to answer questions on homework and exams and stuff like that. So that's really where the trouble is because it's basically all word problems. So you got to be good at word problems to be able to handle this. The math itself isn't that hard, but you have to know what to do. So it's knowing what math to do is the hard part based on the words. And then, as I promised last week, I'm going to get you ready to start project one. At this point, and that's what I begged you last week, you should all have partners for project one. If not, then get on that project discussion board and post and find someone who's looking for one and post back. Or if you don't find anyone looking for one, post your own saying I'm looking for a partner, but make sure you get partners. Okay. And strongly recommend three. You're allowed to have two, but I strongly recommend three because if one of your partners drops and there's only two of you, then that person dropped and it's just you, then you're screwed. So it's much better to have three than two. It's also, if you have three, then you only have to write one third of the project. Whereas if you have two, you have to write half of the projects. And writing half is a lot harder than writing one third. So that's a big deal. Okay, so are there any questions at all about the class or about anything about statistics? Any questions you might have? I do want to remind you that that's like one of the big points of these webinars is so that you can ask questions. Any questions? Yeah, if you have a question, but you don't want to do it, immediately, you can ask now. But you can also always stay after the webinar, and then we can do it. If you don't want to make it public, you can do that, and it's not recorded at once we're done with this stuff. Just let you know. Okay. But if it's something that other people might be interested, this is a good time to ask questions anyway. Okay. Any other questions? Okay. If there aren't, I just want to let you know you can ask anytime, and I'll be looking. Because we're going to be doing probability. So I hope you've all heard the word probability before. You've all heard it, but Doesn't mean you know all the details of it because there's a lot of details. So let me get into the very basics first, and that is what does it mean to say probability? So I think the easiest is simple examples. So you can see I am holding a quarter, and let's suppose I flipped a coin. What is the probability that what I just flipped, you can't see it, but it's there. What's the probability it's a heads? What is the probability? Okay. So first thing is don't give me a percent. Give me the probability. I think you got it kind of, yeah, it's one half. It's one half. So let's talk about that. Okay, so it's one half, and that's because very simply, there are two sides of a coin, and one of them is heads. I'm not cheating. I'm not going to do any cheating in this today. Okay, what if hopefully you know what cards are. I know nowadays people aren't playing cards as much, but most people still know what they are. And if I, randomly pick a card out of the deck, what's the probability this card is a spade? Okay. So the way you can look at it, you're writing some things that are right, but let me tell you a better way of thinking about it. How many cards are in the deck? How many cards are in this is a standard deck, by the way? How many cards? There's 52 cards. And how many spades are in the deck? There's 13. So what you can say is that the probability that this card is a spade will be 13 divided by 52 because it's the total number that make it happen divided by the total number of things that can happen. So probability of heads is 1 over 2. Probability of spades is 13 over 52. So one of the things about probability is you want to think of them as fractions, where the numerator is the number of ways that that thing can happen that you're interested in, and the denominator is the total number of things that can happen. Okay? And we're going to assume that every outcome has the same chance of happening. So, each of the 52 cards has the same chance of getting picked. I'm not cheating. Okay? Any questions? Very simple probability. We're starting easy and we're going to get harder and harder. So here is the definition, the formal definition. The probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. Okay, so you always write a fraction, and this is the notation we're going to use. And mathematicians do this a lot, is we just use the first letter of the word, and that's P for probability. Everyone uses capital typically for that. Lowercase can be used too, but we're going to use it for statistics cases of it. But P, and then you're going to have a parenthesis, and then the event A, and then N parenthesis. That's how you write the probability that A occurs. And then it'll always be a fraction. The numerator is going to be the number of ways A can happen. So when it was spades, there were 13 spades over the total number of things that can happen. In that case, there's 52 cards. Any questions on the definition, the formal definition? Okay, they get harder, by the way. So here's one that's a bit harder. Now same deck. I'll shuffle it out. Now I'm going to pick two cards. So these are two cards from that deck. What is the probability? What is the probability that if I pick two cards, what is the probability they'll both be a king? That one's going to be a little harder. Okay, coming up with the total is really hard in this case. So I don't expect you to come up with this answer, but what I hope is that you're going to listen to it. Okay, so I see you said it's 1 over 169, but that's actually not correct, it turns out. And we'll see that in a little bit. Okay, so here's what we do. We say, what is the probability of the first card is a king? What's the probability? I'm going to call it K1 for this first card that I picked. What's the probability that's a king? And that should be easy. What's that probability? And what I'm going to do is I'm going to insert a symbol, sorry, I'm going to insert math equation, symbol equation, and then I'm going to make a fraction. This is how you use Google and make that work. And what is the probability that the first card is a king? Any thoughts? That's not supposed to be hard. How many kings are there in the deck? There's four kings, so that's four on top. How many cards are in the deck? Also, you're supposed to know that because we just said it. There's 52, so it's 4 over 52. So let's start there. Okay, so you look at the first and say, what's probably that one's a king? Okay, so then what you do is you say, well, if this is a king, what's probably the next one is a king? And that's not going to be 4 out of 52. Because if I said this first one was a king, and I say what's probably this next one is a king, how many kings are left that this one could be? There's three. So what we want to do is that probably the second card is a king. If we know the first card is a king, that's going to be the notation is P of K2, and they have a little line segment, and the word for that is given, K1. So the probability of the second to the king given the first was a king. And again, I'm going to insert, make an equation. Oh, we're in an equation. And then we're going to go to division. And there are three kings left. And then we know that this one is not what this is. So there's 51 cards left that it could be. Oops. Any questions on how I got that? Whoops. Not liking where I put it. Right there. 51. Any questions how I got 3 out of 51? Okay, so then there's what's called the multiplication principle. This is with the word and. I told you and was one of the things we're going to talk about. And the formula is the probability of A and B is equal to the probability of A times the probability of B given A. Okay, that's the general formula. So if I want the probability of king 1 and king 2, then I take the probability of king 1 times the probability of king 2 given king 1, and that's 4 out of 52 times 3 out of 51. And then the rest you stick in a calculator, and I got 0.004524886878. It goes on and on and on. Okay. Any questions on this idea? Any questions? Okay, so this is a probability question. Okay, and it comes up. And by the way, I figured I'd mention this or I'd talk about this because what does this have to do with Tahoe? I know not all of you live in Tahoe, but why is this stuff important? Yeah, we're a gambling town. We got casinos. Okay, I can walk to Nevada, by the way, from my house. I live in California, but it's like really, I can walk in. It's like an hour walk. Other people don't like doing that, but I like walking. So we're a casino town, so this stuff is really important because you need to figure this out. Okay, because if you, for example, own the casino or manage it, you have to decide what the rules should be for your casino so that you make money. Okay, and this is just the beginning of it. All right, so the next question is, suppose you pick 5 cards. So now we're going to get into the casino game. Okay, instead of just a boring 2-card game, now we have 5 cards. What's the probability of getting a royal flush? And again, I don't expect all of you know how to play poker, but these are poker words. Anyone know what a royal flush means? Yeah, about the five cards. What does it mean to be a royal flush? It's one dash a same suit. 10, yeah, I think you mean 10. 10, jack, queen, king, ace, and all the same suit. So what we want to do is we're going to find the probability of royal flush is going to be the number of royal flushes over the number of poker hands. And I'm going to work this out. So the first thing, there are four royal flushes. You can have ace, king, queen, jack, 10 of hearts, of diamonds, of clubs, and in spades. Those are the four royal flushes. The number of poker hands is a little bit harder. Okay. That, there's a number, but of course you would not come up with this number out of your head. My guess is no one knows this number. Um, so the way you come up with this is you say, well, we have 52 cards and you're selecting randomly five of them and there's no replacement. You just take one and you don't put it back in. You take the next, next, next. So that is often mathematically called 52 choose five. And this is something that you do not want to do this by hand, that's for sure. Any guess on how we're going to do it? Don't see y'all jumping in. We're going to use a calculator. Yeah, go to the calculator. Okay. So the calculator we're going to use is number six. That's where we are. We've already done one through five. That was last week. And we're doing number six now. Okay. And that's combinations and permutations. So what we want is we have n, that's the total number, and that's 52. And we have r, and that is going to be 5, because we're picking 5 out of 62. Okay, then it turns out there's NCR and NPR. Okay, NCR is when order doesn't matter, NPR is when order does matter. Those who know how to play poker, does it matter what the order is of the five cards? So if I have an say a king, queen, 10, jack, ace, is that still a royal flush? All of hearts? Some of you might know poker. What do you think? Yeah, that's still royal flush. It doesn't matter what the order is at which you grab the cards. So if order doesn't matter, then it's a CNR. Okay, that's called combinations. Whereas if order does matter, it's PNR, and that's permutations. So I'm going to calculate CNR, and the calculator does it for you. Okay, if you want to find out the math behind it, then you're welcome to come to my student hours, but you're not going to be tested on it. But you need, just in case you're interested, I can, but that's not for now. C stands for combinations. How many combinations are there of five cards where order doesn't matter out of the 52 cards? Whereas P stands for permutations. Okay, so there's our number. Okay, it's not small. It's 2,598,960. So the probability of royal flush is 4 out of 2,598,960, which is really small. Okay. Any questions on that? Any questions? All right, here comes a question about, let's say, you're taking a quiz, okay, maybe for this class. And let's suppose, which isn't quite what we do in our class, but let's suppose that there are 20 questions on the exam. And let's suppose that each one was a multiple choice question. Okay. And you get to choose A, B, C, or D. So there's four different choices. And you have no idea what the answers are. So, but it's better to guess than to leave it blank, right? Because you don't lose points for getting it wrong. You get a 0 for getting it wrong, and you get a 1 for getting it right. Okay. What's the probability of getting them all correct? How do we come up with that? Any idea? Okay. The key on this one is to get them all correct means you got the first correct and you got the second correct and you got the third correct and you got the fourth correct, etc. Does that make sense? So what's the probability of the first correct? This is easy. The multiple choice question, yeah, it's 1/4 because I'm just going to write 1/4 because there are 4 choices and you got to pick one of them. Okay, there's one that's right, 3 are wrong, so it's 1 out of the total of 4 questions. Any questions on that? Okay, how is this different than the card game one? Any ideas? Other than there are 20 questions, that's not important, but there's something really different about it. And especially the two king one is easier to understand. Because if I pick this king, then I can't pick it again. Does that make sense? With the king example, with the two kings example. On the other hand, if I just guess B for the first question, can I bet can B be the second question's answer too? If it was A, B, C, and D? Can they both be B? What do you think? Okay. The answer is yes. Yeah. First question's answer might be B, and the second question's answer might be B also. It happened. Does that make sense? It's just a multiple choice question. Okay. So this is very different because this is what's called with replacement, which means that you can have the same thing the next time and the next time and the next time. So if you want to find out the probability of all 20 correct, what we're going to do is we're going to take the first one, which is 1/4. Then we're going to multiply it by the next one, which is 1/4. Will be the probability the next one's correct. Then we're going to multiply that by the next one, which is 1/4. And we're going to keep going. All right, dot, dot, dot means keep going. And then we're going to multiply by 1/4 again to the end. What's this a definition of? Kind of basic math. If it's 1/4 times 1/4 times 1/4 times 1/4, and I write it down 20 times, how do you rewrite that in a nicer way? X to the fifth, for example. You get the idea, but let's do what it really is. It's going to be 1/4, not to the fifth, but to the 20th, because there's 20 different choices. Any questions on that? Or there's 20 different problems, I should say, to do. Okay. And by the way, that is 0.000000000000909 about. Okay. Very unlikely. Do you agree? Okay. Which, by the way, is about 9 in 10 trillion chances. It's very, very unlikely. Okay. So here's the words I used, and when you're allowed to repeat an answer, it's called with replacement. Okay. And if it's with replacement, the probability of A and B is just the probability of A times the probability of B. Okay. We also call that independent. Any questions on that? So if the probability of A and B equals the probability of A times the probability of B, then we say that the two events are independent. Okay. Any questions on that? Yeah. So with replacement is always independent. There's other examples that are also independent. Kind of what I like to use is, let's suppose that event A is that the is that our soccer team, our Coyotes, win the next soccer game. Got it? And let's say event B is that it is snowing in Antarctica right now. Do they have anything to do with each other? No. If you're given information about our soccer game, does it mean anything in terms of whether it's snowing in Antarctica? No, not at all. So those would be independent, and you still have that formula. Any questions on that? All right, so now lottery. Do you see the lottery? Okay. By the way, uh, a week or two, a couple weeks ago, do you know what the lottery was worth? What was the big winner for how much was the lottery worth if you win? It was $1.8 billion. Okay. It's a lot of money, isn't it? So is it good idea to buy a ticket? So what to find out if it's a good idea, we need to find out what is the probability of winning. Does that make sense? So I bought, when that happened, I bought two tickets. Okay. So what's the probability of me winning the lottery if I buy two tickets? Okay. And this is the Powerball. And first thing is, here you have to know the rules of the lottery. And it's pick five numbers between 1 and 69 and one power number between 1 and 26. Okay, so if you go to the lottery website, you'll learn about that. Okay, so then you got to figure out what's probably my ticket is going to win. Okay, the first thing is, how many different ways are there that I could win? It's very simple. Whereas the next question is not going to be simple, but how many ways are there that I can win? Very, very simple. Not hearing you. All right, I'll tell you. Two, because I got two tickets. I don't know if you can see, but there's two rows of numbers there. That means there are two tickets. So the numerator is going to be 2. So the probability of winning, okay, the first thing is it's going to be 2 for the numerator. So let me go to equation. Whoops, not there. One more time. And then a fraction. The numerator is a 2. The denominator, it turns out that the 5 numbers that you pick from 1 to 69 and the one number from 1 to 26, those are randomly selected. You can even have the same number, so they have nothing to do with each other, which means they're independent. So it means we can multiply. So how many ways are there picking 5 numbers between 1 and 69? Well, let's go to the calculator. So R will be 5, N will now be 69. And again, the order doesn't matter. And you may not know that, but that's true for lottery. So you get this number. 11,238,513. I don't want to have to memorize that, so I'm going to copy it. And I'm going to paste it right there. And then I need to multiply that by the number of ways of the one power number between 1 and 26. That's very, very simple. How many ways of the one power number could be? How many different things could happen? Very simple. Yeah, 26, because there's 26 choices. So it's going to be times 26. Any questions on that? So, by the way, to show you can always go to scientific calculator on this calculator and then put it in. So I'm going to write A over B, 2 on the top. The bottom was 11,238,513, and then times 26. So in case you haven't seen this before, I want to give you a heads up on how to read the answer. Okay, is the probability about 6.8? What do you think? Yeah, definitely not. Okay, probabilities can never be bigger than 1. You can't have over 100% chance of something happening. So 6.8 can't happen. So what are we missing? What are we not looking at? So if you ever write a probability being bigger than 1, you made a mistake. So what are we not looking at? The calculator's not wrong, but we have to read it. Not number of participants. That has nothing to do with whether we win or not, actually. Might have something to do with how much you can win, but not whether you win. Idea? It's this right here, this 10 negative 9. So this is scientific notation. Sometimes you'll see a 10. Sometimes they'll give you a capital E negative 9. You'll see both, or lowercase e. And that means the same thing. That means move the decimal place 9 to 0.9 places to the left. So the first one, you're just going to move it, and then each one after that, you're going to have to stick a 0 extra. So you can have 8 zeros and about a 684. 1, 2, 3, 4, 5, 6, 7, 8, 6, 8, 4. And that's the probability of winning the lottery if you buy 2 tickets. Okay. By the way, should I, go to a real estate agent right now and, put an order on some, multi-million-dollar house because I might win the lottery? You think that's a good idea? No, because look at the probability. All right. Don't assume it's going to happen. It's almost no chance. Okay. It's not 0, but it's very low chance. Okay. Turns out that if you multiply this number by 1.8 billion, you actually get a number bigger than 1. Okay. And that means it's actually mathematically a good idea to buy. Whereas if right now the Powerball is lower, and if you multiply by what it's worth now, you get a number that is much smaller than 1, and then it's a bad idea. So I do the math before I buy my ticket and make sure I do the statistics, the probability, and I make sure that, hey, I got that, makes sense to buy. Any questions on kind of using the site and stuff? Okay, so let's continue on. All right. So here's the example. Suppose that 20% of all students taking stats at Lake Tahoe Community Colleges are African Americans. Okay. By the way, if I write the word suppose, I want to give you a big heads up in this class. That means I'm making this up. It means it's almost certainly not true, but I just wanted to give you either example with nice numbers. I could have looked it up, but the numbers wouldn't be as nice, so I wanted to make the numbers nice. So that's what my suppose means. It means don't cite this as a for resource, that this is true. But let's suppose that 20% of all students taking stats at LTCC are African American, and 40% of all stats students in LTCC are non-STEM majors. If 22% of LTCC stat students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability the student is non-STEM. Okay, so you might be convinced at this point why this chapter is hard. Okay, maybe I'm wrong, but my guess, are you all like great at these kind of big paragraph word problems? Or this stuff is hard for y'all? Yeah, I'm not saying I'm great at these word problems, so that you can see why I'm saying that this is a tough chapter. Okay. It's not that hard to watch me do it, but doing it yourself is much harder. My the analog I like to give is this is very similar to kickboxing. So is it hard to watch two people kickbox? Not at all. But what if you had to kickbox? Do you think that's hard? Yeah. And trust me. Okay. Remember, I teach math. I think you know that and stats. Any guess on what I've also taught? Yeah, I haven't kind of kickboxing, but martial arts. So I've taught martial arts too. So I know because I've kickboxed. It's much harder to do it than to watch it. Just let you know. And this stuff is the same way. It's much harder to have to do your own, have to solve problems by yourself than to watch me do it. So I'm giving you a big heads up that just because you're watching me and you're following everything I do does not mean it's easy to do. Okay, but I'm going to tell you kind of a step-by-step process that might help. So whenever you have a long word problem, and in our class, by the way, not just this chapter, but in our class, we're going to have a lot of long word problems. The very first thing I recommend, well, the very first thing you should do is read it. And then the next thing I recommend you do is read it again slowly. And every time there's a number, write down what that number represents in symbols. So suppose 20% of all students taking stats at LTCC are African Americans. So I'm going to write probability of being an African American is zero point 0.2 because 20% is 0.2. Does that make sense? After reading that phrase. 40% of all stat students at LTCC are non-STEM majors. So I'm going to use N for non-STEM, and I'm going to say P of N is 0.4. Any questions on that? Okay. If 22% of LTCC stats non-STEM majors are African American, okay, so now we're saying we're going to just focus on we're going to focus on the non-STEM majors, and 20% of them are African American. So we're given the person is non-STEM, and then we're going to say we have a 20% chance that they're African American. So that, the way you write that is P of A, and then a little line segment that's given, N equals 0.22. Any questions on reading that phrase and turning it into symbols? I will let you know if you can't do it, you're not going to be able to do a lot of things in this chapter. So make sure you ask questions if there's anything you don't understand how I came up with this. Okay, then the next thing I recommend doing is figuring out what our goal is. We want the probability that the student is non-STEM. If we pick, so let me read, you pick a randomly selected African American taking stats, find the probability the student is non-STEM. So now we were told they're African American. So that means we're given A. We want to find the probability of N. So we want the P of N given A. Any questions on how I was able to write down what my goal is? I always write equals question mark, and that tells me that's my goal. So that's what I want to find out. Any questions? Okay, so then we remember there was that formula we had, and that is probability of A and B equals the probability of A times the probability of B given A. And the reason for that is the probability of B given A was the probability of A and B divided by the probability of A. There's lots of ways of writing this, so I'm just writing it. And the probability of A and B is also the probability of B times the probability of A given B. Hopefully you know that if I say A and B, that's the same thing as B and A, right? So for example, I'm going to tell you that I live in Tahoe and I teach math. Is that any different than saying I teach math and I live in Tahoe? Yeah, not at all. I mean, hopefully you know the English it's the same exact thing. So switching the A and B doesn't change anything, but that means if the first one you can think of as A and then B given A, or the first one is B and then A given B, because replacing A with B and B with A doesn't change anything. That's what we just did. So that's where that formula comes. Okay. So if I take this formula and I divide left and right by probability of B given A, then I can say that the probability of A given B is the probability of A and B divided by the probability of B. Any questions on that? Just taking that first formula line and dividing by probability, or the second formula line and dividing by the probability of B. Okay, so that means probability of A and N is the probability of N times the probability of A given N. And the probability of N given A is the probability of A and N divided by the probability of A. Anyone lost on that? Okay, so is N coming from the symbol from the word problem? Yeah, N is this N here, and if you remember, that was the non-stem in the word problem. So again, A and B, those are the standard letters, for the formula. But then in the real world, you want to use letters that represent what we're talking about, and N was non-stem. Good question, very good question. So the probability of A and N over the probability of A, that one, well, the probability of A and N is what? So we got to find that out. Okay, the probability of A and N is the probability of N. Probability of N was 0.4. And then the probability of A given N, that was 0.22. That was the whole point of writing all that out. So then the probability of N given A is probability of A and N. That's 0.4 times 0.22. By the way, 4 times 2 is 8, so this is 0.088. And then we're supposed to divide that by the probability of A. And the probability of A was 0.2. Any questions on that? Okay. And when you do that, you get 0.44. You can stick it in the calculator if you want. Any questions on that? So here's that key formula we just did again. Let's see. Okay, so now let's suppose you roll two six-sided dice. So back to gambling. So you roll two six-sided dice. Okay, I just rolled two six-sided dice. I'm not going to tell you what I got, but there's two dice in my hand. Okay, and I rolled them. What is the probability the sum is a 5? If you add up those two dice, what's the probability that they add to a 5? So let's think about it. Well, you can say 2 out of 6, but let's think about this carefully. What you have to think about is how many ways are there getting a 5? So, because we're going to have a fraction, right? So how many ways of getting a 5? Well, you can have let's use my fingers. You can have a 1 and a 4. You could have a 2 and a 3. You could have a 3 and a 2. You could have a 4 and a 1. There's 4 ways of getting a 5. Do you see that? There's not one way of getting a 5. There's 4 ways. Because those are the 4 ways. How many different possibilities are there? And not numbers, but how many different possibilities are there for the first die? That's easy. 6. How many possible ways are there for the second die? Also easy. Also 6. So think about it. The first die could be a 1, and then there's 6 that the second die could be. That's 6 different choices. Then it could be a 2. That's 6 different choices. It could be a 3, 6 different choices. So there are 6 ways of choosing 6. So how many total choices are there? We have 6 choices plus 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 6 choices. There's 36 choices. And 4 over 36 will be the probability the sum is a 5. Any questions on that? Okay, just want to give you a little heads up for the homework. Make sure you read what it asks you to do. If it says write it as a decimal, you need to stick it in a calculator and divide. If it says write it as a reduced fraction, you'd write it as 1/9. If it just says write as a fraction, then you can write 3 over 30, 4 over 36. So make sure you read the instructions on the assignments. Any questions on that? Okay, so now we're going to do what's called a contingency table. Okay, so here's an example. Let's suppose a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring and what living situation they're going to be when they transfer. And let's say the answers. Some wanted to transfer at Cal State University, CSUs. Some wanted to transfer to UC's, University of California. Some wanted to transfer to UNR, which is University of Nevada, Reno. And then there were other people. Someone might have wanted to transfer to Stanford, for example, or some other place. So just call those others. And then the living situation, some want to live in an apartment. Some are going to live with their parents. And then there's other people. And I have all these numbers. This is called a contingency table. So let me explain how you read these numbers. For example, this number 8. That meant of the students who took the survey, 8 of them are planning to transfer to a UC campus and live with their parents. Does that make sense? Okay, so a question was about the exam. So I was going to wait a little bit, but let me tell you now since you have a question. So note that we're in week 2. What's important about the number 2? What's important about the number 2? No one knows. It's even. Why is that important that it's an even number? Yeah, it means it's test week. Even number weeks are test weeks, so we're going to have an exam this week. Okay. The exam covers everything from week 1 and week 2. Okay, so that means chapter 1, chapter 2, chapter 3. So what I strongly recommend is getting this week's chapter 3 stuff done early, maybe by Thursday or something, so that you're ready to start practicing for the exam. And I do want to let you know you can always go back and do practice problems from the questions from chapters 1 and 2. How many questions are in the exam? I don't even remember, but that shouldn't make any difference on how you're going to study. They're usually 20-ish. And the way it goes is they're randomly selected. Most of them are randomly selected from the chapter assignments you did. And then the last few that you have to do are word problems where you have to type out the words. So the study guide is the following. Chapter 1 assignment, chapter 2 assignment, chapter 3 assignment, because they're randomly selected from those assignments. Does that make sense? And the discussion post assignments, because that's kind of like tells you what the word problems look like. So does that make sense as a study guide? So, and again, you can always go back and do problem after problem after problem. So you can do lots of random problems. So that's the study guide. Okay. And then the big difference between the exam and the assignments is the exam is timed. You have 90 minutes. Okay. Unless you have some disability and you needed extra time, but otherwise you have 90 minutes and it's over at that 90 minutes and that's it. If you didn't get to the last 5 problems, you get zeros on all those. Any questions on that? I do want to give you one more heads up, is that the ones that I grade will show as 0 points until I grade them. So let's suppose you took the exam on Saturday, then your score won't be great because the written problems will show as 0 points until I grade them, and then your score will go up. Hopefully, if you did well on them. So, don't freak out about those 0 for the ones that are word problems, the last few problems at the end. So the written problems, a lot of them are like what you have to do on the discussion assignment. Okay, and they could be other types of things too, but that's a main one. They could also be if I have any writing stuff I have to do, but that's the main stuff, the discussion assignments, where you're going to have to analyze something and then write about it and do some statistics sometimes. That make sense? Okay. So let's move on a little bit. So here's this contingency table. So here's the question. Find the probability that a randomly selected student will go to a UC campus or live in an apartment. And just note that if you add 43 plus 33 plus 19 plus 22 plus 34 plus all these other numbers, trust me, you get 246. So there were 246 students that answered the question. Okay. So here's a very important formula. And that is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Any questions on that? Okay, and the reason why that's true is if you add the probability of A and the probability of B, if you add these two probabilities, then you're kind of double counting the ones that are both A and B. Because you get the A's, the ones that are both A and B come here and also come here. And you end up double counting, so we're gonna subtract off the A and B's, and that way they become single counted. That's the math behind it. You don't have to know it, but you have to know the formula. Okay, and you're always allowed to have, for everything you're doing in this class, you're allowed to have your formulas written next to you. So for the exam, for example, you can write, but don't use AI, I can tell. And boy, am I going to mark you off. Don't use AI to do your exams. Yeah. Or any of your work, basically. You can use it for learning, but not for doing your work. Because I'm very good at telling. All right, so the probability of A or B, instead I can write the probability of, we want UC campus or an apartment. I'm going to call that UC or A for apartment. And that's the probability of UC plus the probability of apartment minus the probability of UC and apartment. Any questions on that? Equals. So then, let me do the following. That way we can see it. Okay, so now let's see what it equals. Probability of being in a UC apartment. So let's take a look at that. And I'm going to write as a fraction. These are probabilities. So for the UCs, it'll be 33 plus 8 plus 19. Those are the UCs. 33 plus 8 plus 19. And then we're going to divide it by the total number of students, and that was 246. Any questions on that so far? And then we're going to go plus the probability of A, so that's apartment. That's a fraction also. Well, the apartments are 43, 33, 19, and 22. So I can go 43 plus 33 plus 19 plus, and then 22. And we still have 246 students. And then minus. Now I'm going to do a fraction again, another probability of UC and A. How many students want to go to a UC campus and live in an apartment? Why do we subtract? I mentioned that a bit ago, and I'll mention it after we get this down. So if you didn't understand what I said, I'll say it in a different way, but let's write this down and then we'll see. How many students want to go to a UC campus and live in an apartment? Yeah, 33. And there were 246 students. So your question was, why do we subtract the probability of UC and A? And the reason is this 33 here is double counted. Do you see that? It's counted in both these fractions. And that's the reason why it gets subtracted. Does that make sense? But even more important, get this formula written down. It's good to understand it, but get a formula written down. That's more important. But that's the reason why the formula works. Okay, I am not gonna, I don't think it's worth wasting your time and actually, calculating these. Hopefully you know how to put numbers in calculators. You're always welcome to use a calculator. So you just pop that in a calculator and it'll give you the answer. Sound good? All right, so now a couple definitions. The first is two events A and B are mutually exclusive if the probability of A and B equals 0. So kind of the idea is that A and B can't both happen. Does that make sense? Because that's what it means for the probability of A and B to be 0, is you can't have A and B. because probability of 0 means it's not going to happen. Is that clear? So are transferring to a CSU and living in with parents mutually exclusive? Okay. So if you look at the CSU and living with parents, there were 34 of them. So 34 is the numerator, 246 is still the denominator. Hopefully you don't need a calculator to know that's not 0. And if that probability is not 0, they're not mutually exclusive. Any questions on that? And kind of in like the understanding, the language, and not the math, but the ideas, is that yes, you can have a student that wants to go to a CSU and live with their parents. In fact, there were 34 of them. So hey, it can happen. So the probability is not 0. Is that clear? Okay, the next definition, which I've mentioned, but now I'm going to mention it in formality, is two events A and B are called independent if any of the three are true. The first is probability of A and B equals the probability of A times the probability of B. The second is the probability of A given B equals the probability of A. The third is the probability of B given A is the probability of B. So I think this second and third are easier to understand. So if you're told B happened, that doesn't change the probability of A happening. Okay, kind of an example of that. Let's say I flip a coin and then I pick a card. Are getting a heads and picking a king, are they independent? And the idea is if I told you this is a head, is that going to change the probability that this is a king? What do you think? Yeah, it doesn't change at all. If you know there's a head, it doesn't tell you anything about the card. So that's the way kind of seeing this is that if you're told it's a head, then the probability that it's a king is still the probability of the king when you haven't been told anything. Okay, that's kind of where that's coming in the idea. And it turns out if one of these is true, all of these are true. So then the question, are living in an apartment and transferring to UNR independent? So that is we calculate. And you could choose any of these three. And if whichever one you choose works, then they're independent. If they don't work, they're not independent. So let's choose the probability of apartment given UNR. So then notice that there are 19 students that are in an apartment and UNR. So that's the numerator divided by the number of UNR students. The number of UNR students is 19 plus 7 plus 15. 19 plus 7 is 26. 26 plus 15 is 41. So that gives us 19 over 41. And I put it in the calculator and I got 0.46341 approximately. But then if we don't have the given, the probability of an apartment, well, then we count the apartmenters. That was 43 plus 33, which is 76, plus 19, which is 95, plus 22, which is 117. So that's 117 over 246. And when I calculate that, I got 0.4756. So notice 0.46341 is not the same thing as 0.4756. So they're not independent. And by the way, the word for not independent is dependent. So we can say they're dependent. Anyone lost on what we just did? A lot of word problems. Any questions on this? Okay, so the next thing I want to do is give you a secret word. And the secret word is number. And that's because when you're doing probability, you want to say it's the number of ways the event can happen divided by the total number of things that can happen or ways that things that can happen. Okay, so number, because number is really important when you're talking about probability. So that's your secret word. Write it down. If you're not paying attention right now, you're screwed, but you don't know because you're not paying attention. Then you're going to have to watch it on YouTube. So what I want to do next is talk about the project. So let me go to the syllabus and I'm going to show you all the things about the project. Okay. So the first thing is if you look at this, project one says by October 19th. Okay. Which is a little less than a month from now because today is the 23rd of September. So you have time, but don't wait till the 18th to start working on your project. That's a very bad idea. I'll get into kind of suggested progress. In fact, what should you have already done it, which I already told you today? What should you have already done about the project? Yeah, found partners. Okay, not get partners now. Worry. So partners are really important. And it's not that hard to find them. You just post on the project discussion board. But if you wait a while, then it will be hard because everyone's found one and then you're screwed. So that's why you don't want to wait forever. So you want to get partners. All right, so that's one thing. All right, so let me remind you a few things. Two projects are created. So we're going to talk about project one. You're going to collect quantitative data. Do you remember what quantitative data is? What that word means? We talked about it last week. What's quantitative means? It's one of our vocabulary words last week. Yeah, it means that the answer to the survey question is a number. Okay? You're going to use computer to display each of the charts discussed in the class. Okay, and the statistics, it turns out. Okay. You're going to need to use the Google spreadsheet, and we'll get in. I showed you that a while back, and I'll show you it again later. Okay. So if I click on Google Sheets spreadsheet program, that was this guy. The first thing you do is you go to File, Make a Copy, give it a name, and hit Make a Copy. Okay, I'm not going to because I already have my copy. That's the first thing you do. The next thing you want to do is hit Share. And you're going to go to Viewer and make it Editor. I'm not going to do that now. And then you're going to copy link and then email it to your partners so that you all have the ability to work on the same spreadsheet. Any questions on that? The next thing you're going to do is you're going to highlight all these numbers, 1 through 14, hit the backspace, and that'll erase the numbers that are there. Now I'm going to put them back. Oops. But you want to erase the numbers so that you can put your numbers in. Then you can put your numbers in, and it'll give you all the important stuff. Mean, variance is not important. Sample standard deviation is important. Median is important. Maximum is important. Q3 is important. N is important. This SNL, that's stem and leaf. Then you're going to have a Q1, first quartile. You're going to have box plot, just leave that, it's fine. Don't worry about confidence. That's not part of the project. Don't worry about H1, it's not part of the project. And then Z-score. Note this says change this. So don't just leave 36, 35 there. You're going to find Z-scores that are important for your project. Talk about those in a little bit. Okay. The IQR is important. Okay. And none of the others are important. Is this filled out spreadsheet? Yeah, when you go, when you hit make a copy, you'll see this. Does that make sense? And where do you find the Google Sheet? So if we went to the syllabus, see what it says projects, you click on Google Sheet spreadsheet program. Got it? That's how you find the Google Sheet. Is that clear? So that's what I did. I clicked on that and it popped that up. And only one of you needs to do it because then you're going to share it. Otherwise, you're going to have different ones and you want to have a shared copy. Okay. Now let me click on project one. And that's going to send us to the details of the requirements for project one. Okay, so you're going to think of a quantitative investigation where you ask people a survey question that someone might contract out to have done. Okay, if nobody would be interested in your study, it doesn't work for the project. You need to find something that's interesting. Then you're going to go and perform the investigation, produce a report on it as though you were handing the report to the person paying for your services. Okay. And by the way, this person is, in theory. So for example, your person could be President Trump, for example, if he might be interested in your results. But that doesn't mean you actually have to contact Trump because good luck. Very hard to contract, the President of the United States. But you can pretend you've contacted him. Does that make sense? Okay. Or it might be the, counselor at at the college. It could be the manager at the where you work. I don't know. Lots of things. It could be the CEO of Safeway supermarket. I mean, again, you don't have to actually find the person, but it should be a person. Does that make sense? Has to be a person. And you can always look up who that person is so you have a name. Okay, so the purpose of the project is to make recommendations based on your finding. Okay, so throughout your entire paper, you're going to be making recommendations. So for every single thing you do, you're going to talk about what you recommend or how you recommend your client to use that thing. Okay, that statistic or that chart. Make sure that in your paper you write down who has hired you and why they're interested. And again, this is all theoretical. Even they're not going to really hire you, but you're pretending. Does that make sense that they're hiring you? Any questions so far? Just a note, and this is important. Here's who you're not going to ask. I think I already mentioned this. You're not allowed to ask children. Anyone know why you're not allowed to ask children? There's a reason. They're too young, but in particular, you can get sued. And you don't want a lawsuit. It's actually against the law to ask children without all kinds of signatures from parents and paperwork and all kinds of stuff. That's the reason. And this is going to be on YouTube. I have said it. So if you get sued, they can't sue me also because I've told you can't do it. So do not ask children. The only kind of children you're allowed to ask, if it's a college student who happens to be 17, then their parents sign that off that you're allowed to ask them. But you can't go to, say, a high school and ask the high school students. Okay, you're just not allowed to do that. Okay, there's all kinds of legal reasons, so don't do it. Got it? Okay, so here's what you have to put in. You have to have a description of your sampling technique, okay, that was made and how the technique was applied. So how you did the sample. And the choice of the sampling technique are simple random sampling, stratified sampling, or cluster sampling. Why do I have links to stratified and cluster and not a link to simple random? There's a reason. Let me guess. Don't see it. Okay, let me tell you the reason is it's almost always impossible to do a simple random sample. So, so think again. But stratified definitely happens, and cluster sampling, those are the two that are not too hard to do. Okay? And if you click on the link, it'll remind you what they are. That's all that is. I'll let you look at that. Okay, discuss any bias that might have occurred due to your sampling technique. Okay? So note that bias involves a misrepresentation of the population. So the sample data may not represent the population data. In particular, you should talk about, based on the bias that you have noted, is the sample mean likely to be less than the population mean or greater than the population mean? If the sample mean is likely to be the same as the population mean, that's not bias because it doesn't change the mean. Do you see that? So make sure you get that down. Okay. So make any findings of potential bias should provide a convincing argument why you think the sample is more likely to have a higher or lower mean. Okay. The variable must be quantitative. I've already said it, but I'm reminding you again, that's a mistake people make, and it's a disaster if you make that mistake, if you use qualitative data. Okay. Has to be quantitative. What I recommend is survey your partner, and if your partner answers and it's not a number that out of his mouth or her mouth, then that won't work. Okay, the sample size must be greater than 30. By the way, the number 30 is not greater than 30. What's the smallest sample size you're allowed to have? What's the smallest sample size you're allowed to have for this project? Yeah, 31. Okay. I don't give you more points if you have a sample size of 1,000. So no reason to waste your time. The only reason to do a sample size of 1,000 is if it's also for your own work, for your job that you have, and your boss wants a really big sample, then that's different. But 31 is fine. Okay. You might end up doing 33, for example, if there's three of you, because then you can each do 11 if you felt like it. Do you see how that works? Okay. Be careful not to use the word random with it fully explaining what you mean. So in your project, if you said you randomly selected people, boy, good luck. It's almost never right. Okay. And then I mentioned simple random is almost impossible to use. Any questions about the sampling? Okay. A couple notes, and this is kind of legal stuff or, moral stuff. If you're going to go to a business and ask people a survey question, make sure you talk to the manager of the business and get the permission to ask. Okay. And if you're going to go to a college and ask people in the classes, then ask them, make sure the professor's okay with it. Okay. If it's one of my classes, you don't, because I'm always okay, but everyone else may not be. So make sure you ask the professor if you can do it before you do it. Does that make sense? Because I don't want anyone getting in trouble because of this project. Okay. So get permission and another suggestion I have, and this helps prevent bias and especially voluntary response bias. If you tell the person that you're doing this for your elementary statistics class and it's your project and you have to do it, they'll almost always answer your survey question and they'll feel sorry for you. If you don't tell them that, a lot of them are just going to walk away. Does that make sense? So that's just a suggestion. It's much easier to get people to answer your question if you let them know that this is for your statistics project. Okay. Now, you have to have all relevant charts. Okay. And three that are absolutely required are the histogram, the stem and leaf, and the box and whiskers plot. Those are the three we talked about last week. Okay. Any questions on that? Okay. So just to note, if you're here and you want to get so the histogram is already there, but if you want to get the box and whiskers and stem and leaf, you click stats and you click box plot. And there it is. And then hopefully you know, and this is very important, that how to copy and paste, do a screen capture. And then especially a screen capture where you can use your mouse and say just this part. Okay. Similarly, you can right click this and you can copy and then paste it onto your project. You must also copy and paste these guys, these columns, and that has to be in your written project. Okay. I take a lot of points off if you don't have that in there. Okay. It's really important. I want to let you know AI won't do it for you. Don't use AI to do your project. So that's one of the ways I stop you from using AI. I don't want you to just use AI to do your project. Okay. If you want to get the stem and leaf, you go to stats and you go stem and leaf. And there's a stem and leaf. Okay. Any questions on that? Okay. I do want to let you know that if all of the answers are single digit, the stem and leaf is useless. So make sure that you have answers that are not just single digits. So when you're thinking about your survey question, make sure that people are going to give you not just one, two, three, four, or five. So, for example, don't ask someone, for example, how many times in the last week did you go to a restaurant? Almost no one is going to say anything over 9. Does that make sense? Instead, if you wanted to kind of use that idea, you would change your survey question to maybe how many times in the last year have you been to a restaurant? And then you're going to have lots of 2-digit numbers. Do you see that? So think about how you can adjust your survey question to make sure that you have 2-digit numbers. Any questions on that? So your question was, can the question be that basic? Only if you're interested and you can think of a client who might be interested. Does that make sense? And then the question can be basic. It's not supposed to be some like miserable. This the survey question. You're just asking one question, unless you're doing stratified sampling, and then you're asking two. If you're doing stratified sampling, the first question would be, what is your strata? So if you're doing stratified by race, then what is your race? Does that make sense? And then the second question would be the quantitative question. How many in the last year, how many times you've been to a restaurant, that kind of thing. Make sense? If you're doing cluster sampling, then it's just one question. Something like how many times you've been to a restaurant in the last year. Any questions on that? Okay, so you have to have all these. All charts and statistics must be done using the spreadsheet program that I just showed you, not a calculator. Okay, this is not a comparison study. Okay, if you're doing stratified sampling, let's say you're doing, I don't know, online students versus face-to-face, you're not comparing online and face-to-face students. You're making sure that you have a proportionate representation of each. So there should only be one column of data. If you have more than one column of data, you've made a mistake. Got it? That's a common mistake. Don't make that mistake. Okay. So there's only going to be one mean. That's it. Not two means. There's only going to be one standard deviation. Okay. Etc. Okay, you must interpret each of the charts in the context of your study. So for each chart, okay, talk about what the chart says and does not say about the population, and make sure that you relate it to your client. Remember, the entire project is not to me. The entire project should be worded for your client and the needs of your client. Got it? Okay. So compare and contrast the charts. State what audience each chart might be best for. So hopefully you understand that. Okay, then a list of summary statistics. And make sure you interpret each one and talk about the decision the client will make based on each summary statistic, one at a time. So this includes the mean, the median, the standard deviation, several others I kind of showed you a little while ago. First quartile, third quartile, the interquartile range, okay, z-score, okay. Okay, and by the way, use the z-score to decide if there are any outliers or not. Remember, an outlier means the z-score is greater than 2 or less than -2. That's our definition of our outlier. Okay. Pay special attention to the standard deviation. That's very important. Okay, it's our newly learned statistic for the project. Projects without at least a full paragraph devoted to the standard deviation cannot receive an A grade. Okay, in particular, is the empirical rule appropriate, or must you resort to Chebyshev's theorem? Okay, does the ruler theorem, what does the ruler theorem say about the population? Talk about, what decisions the client is going to make based on all these different things. Discuss how to use a z-score for your study. Okay. And again, what I recommend, make sure you look at the max and the min and maybe some of the other higher ones to see if you have outliers. Okay. And then if there's any very important numbers, then do that one too. So for example, if your survey question was, how many minutes of sleep did you get last night? Then notice that the, recommended is 8 hours. And by the way, 8 times 60 is 480. So then you would maybe do the z-score for 480. Okay. Make sure you interpret all statistics in this project in the context of the survey rather than just the definitions. And make sure you explain what decisions the client will make. You should give a synopsis of the importance of your finding. So just a note, this is a paper. Okay. This is a paper. And hopefully you learn in your English classes. And how does a paper start? A written report. How does it start? You learn this in English. This is not a math question. You're supposed to know this. With a title? Yeah, you should have a title. That would be like a title page. So you should have a title. You should have your names on it, by the way. Okay, make sure each of your names is on it, of the project partners. That's important. But then in terms of after the title page, yeah, an introduction. Okay, you should have your introduction. So a paragraph of introduction. How should it end? What do you call it in English? Yeah, conclusion. So those are the main points and the main takeaways for the client. And then there's a big long body in between those. So just let you know that this is a report. So all that has to happen. Okay. All right. So you should have a synopsis of the importance. Okay. You're writing a paper with the sheet. So you're using the sheet and then you're writing and you're going to copy and paste that either directly where you're talking about it or at the end of the paper. In paper, I mean, it's on computer, of course. So it's not true paper. So one file submission. Yes, only one of you needs to submit it. As long as all your names are on it, that'll be good. Okay. All right, so make sure that you have a synopsis, include recommendations that you will give to the client based on the mean, the standard deviation, IQR, each of the charts, etc. In your recommendations, include the specific values. For example, if your study was the age that students first learned the quadratic formula and the mean was 15.3, don't just say, the mean could be used to understand when people learn the quadratic formula. Okay, you haven't talked about how it's used. Instead, you're going to write Students are learning the quadratic formula on average just after they turn 15 years old. Do you see? And then you'd say, and my client, who is, I don't know, the math teacher at the high school, and you would say that going to make sure that they're going to, by the time they're 16, that math teacher better have shown them the quadratic formula. Do you see how that works? Okay. So, and maybe you should not have chemistry as a freshman because they haven't learned the quadratic formula yet. Do you see that? Okay. Any questions about this? Then you should also have a discussion of how further studies can be done in order to delve deeper into the topic. You don't have to do a further study, but just talk about how you could do one. Any questions on that? Just a timeline idea. So by today, what should you have already done? I've said this 3 times today already, I think. So first thing in your timeline was find partners. And I recommend not a partner, but 3 people. So two partners beside yourself. So that's day 1. That's first week. Okay, then I recommend by next week, so a week from today, you have talked to your partners, and that can be online. Again, you can do this whole class online, that's fine. And talked about what your survey idea is, what your survey question is, who your client is. Does that make sense? And how you're going to conduct your study. Any questions on that? Then what I want you to do is post on the Project One discussion board your idea. I'll look at it and let you know if it can work and also what modifications you might need to make so that it can work better. Does that make sense? So I recommend that within a week. Okay, and again, all your partners should have decided on this together. So it should have your survey question, should have your sampling technique. Those are the 2 main things. And post that in the Q project discussion board. That way you can see what other people's ideas are to kind of see what works and what doesn't work, because I'll reply to it. Do you see? And again, this is 1 per partner group. Yeah, that's my recommendation by next Monday. Does that make sense? Then after I look at it and let you know, which might be a couple days, but probably not. I do want to let you know there is a small chance I'm going to be very busy Monday. I really am crossing my fingers that it won't happen. Any guess what it might be? Chance I may not even have student hours. No, not sub. And it could be Tuesday, it could be Wednesday. Nope. When I say, you'll laugh. Should I tell you? Jury duty. I have jury duty next Monday. And I don't know if you know about it, but I can't do anything about it. So there's a chance that my whole schedule's going to be changed. I'm going to be stuck in court seeing whether the person's guilty or not. Hopefully not. Hopefully it gets canceled. So I'll let you know. I'll send out an announcement if I'm not going to be there for student hours, for example. The good news is webinars nighttime and jury duty is never at night. So that won't make a difference. But student hours could get canceled. Sorry about that, but I don't get to choose. I got the letter in the mail. So anyhow, I figured I should mention that. Okay, so then after I have let you know it's going to work, the next thing you should do will be to conduct a survey. Go and ask the people. And you could each conduct, say, you ask 11 people each if there's 3 of you. See, that's easier. And that's 33. If 1 person wants to do all of it for that part of the project, that's fine too. But you better have, at least 31 people that you survey. Any questions on that? Okay, so that's the next piece. Okay, the survey shouldn't really take more than a week. Then after that, you should get together, put it in the spreadsheet, write up your draft of a project. And again, the project is due. Let's go back. the project was due on the 19th. So I recommend that maybe around like the 13th or so, or the 12th, send me your draft. Okay? And then it might take a couple days, especially if a whole lot of people send it once. I'll give you lots of feedback. And then I recommend by the 17th or 18th, that's when you put your final copy in Canvas, not email to me, but in Canvas. There's a project submission. Okay. Your draft is emailed to me, but your final project is submitted on the Canvas assignment. Okay. So I recommend sending it like a week before-ish, like the 12th or 13th. If it's not by Thursday at 8 a.m. on the 16th, I won't even look at it. Okay. And I only look at one draft per group. After that, you can talk to a tutor. That's fine. The problem with online surveys is it's a very bad response rate. So it's better to do face to face if you can. And it's not that hard to do. It's 11 people you're asking each. Do you see that? It's really not that hard. So it's probably easier to do face to face. Okay. All right. So that, and then that is kind of the whole point and the main thing on the project. We're a little longer than I usually go. I told you, but I did say plus or minus 10 minutes, so it's 7:37. But I think I am going to call it a webinar. And I'm going to remind you, I'm always, after I stop the recording, then I'm always up for questions if you have them. And we won't be in recorded time, so it's private. So I'm going to stop the recording. Thanks for watching.